Hi, we're at Texas Media Systems, and I just wanted to preface the Sennheiser seminar video you're about to watch. Back in April, Sennheiser came to Wire Studios here in Austin, and they gave a seminar about different mic techniques and how to use Sennheiser products. We were lucky enough to go and videotape Christopher Spahr as he gave this seminar. The entire presentation was 3 hours long, but unfortunately, several parts of it did not translate well to video. If you stay tuned to the end of the seminar video, you'll see a short little montage of the local band, Digital Antique, as they use these mic placements and microphones that are discussed in this seminar to practice. Enjoy!
So, you guys met Joe Chowdelli, my boss, the director of our market development and education department, and we do things like this. We do the trainings and the educational stuff and a lot of troubleshooting, a lot of tech stuff. Hey, come fix this. Hey, coordinate our wireless frequencies for us, that type of stuff. And we support the sales staff, which you guys know some of the sales guys that got you in here probably. So, what is a microphone? Basic question. It's just a transducer, just like a headphone is a transducer inside of there. Just works in reverse. This converts acoustical energy into electrical energy, and a speaker or a headphone does the other way around. Couple of microphone types. These are the big ones, dynamic and condenser, which we'll talk about. Ribbon I also put in there as kind of its own thing unto itself. And digital microphones, which is a whole different ball of wax. And I wanted to put it up there as a separate microphone type because it's so, the ones we're going to be talking about are so very different. So dynamic microphone, very, very basic. A couple of components, a diaphragm and a voice coil and a magnet. That's it. Doesn't require power or anything. Larger mass than condenser mics, and we'll talk about condensers in a second. No power supply at all. No need for phantom power or any kind of external power supply. Very low sensitivity, which we'll see what condensers look like. High SPL handles a lot of power going into it at low distortion levels, which means you can stick this in front of a cabinet, some kind of a Rhodes, speaker cabinet, a Leslie, whatever, a big Marshall stack, and it's hopefully going to handle it for you without any kind of distortion. So the inside of a dynamic microphone. Again, very basic. Diaphragm, voice coil, and a magnet. That's all it is. Condenser mic, a little bit more complicated. Diaphragm and electronics. And this is where you need that phantom power. You need some kind of external power supply, either phantom power or its own power supply to provide voltage to the diaphragm. It also biases the capsule, amplifies the signal. Much greater sensitivity, so a lot better at like transient response, grabbing a fast attack from a snare drum, for instance, something like that. Distortion is limited by the design of the electronics. So most of the time, current condenser mics, you don't have to worry about them distorting on something loud. Depends on the microphone, but again, up to 154 dB for a condenser mic, that's Marshall stack loudness, which is fine. Again, here's the condenser mic again. Here's your diaphragm. Here's your back plate that's charged. And these little grooves in here, the ratio of these grooves gives you your polar patterns. So, and the ones that go all the way through are omni, and then these halfway through are cardioid, and then the different ratio determines polar patterns. So, and a different type of condenser mic is something called an RF condenser microphone. It's very cool. Sennheiser is really the only people doing it now for some strange reason. It's very costly to manufacture this way, and I don't know why people stopped doing it. Anyways, the end of the 50s, you went from tubes to transistors, and it gave us a problem. The input impedance was too low for condenser capsules, so we had to figure out a way around it. And they did this capsule impedance thing with this RF technique, why this is called an RF condenser. But there's an actual oscillator that generates a tone from this little RF bridging circuit in the microphone. And it generates voltage. One of the byproducts of doing microphones this way that they kind of found out after the fact was this low sensitivity to humidity and moisture. If you're doing anything outside, these types of RF condenser microphones are by far going to work where other things are not going to work. If you have to do something in the Florida Everglades and you're outside for 2 weeks doing some kind of recording, the MKH stuff is awesome for that. Oh, it's fantastic. It's the only thing that really will work. I mean, you can take a Neumann out there, you can take another Sennheiser shotgun out there. They're probably going to crap out with moisture, any microphone. It's just they will, and these things won't. Very cool microphones. Couple reasons why. You know, high sensitivity because of this improved acoustic efficiency of these microphones, and I'll tell you a little bit about why the acoustic efficiency is improved. But there's really no acoustic resistance in the capsule. Sometimes in the capsule there's actual material in there that alters the frequency response in a certain way. So if you look at a frequency response of a capsule, it looks horrible. Things are all over the place. They look bad. And then you basically will tailor the microphone to get that response to how you want the mic to sound with acoustic materials for the most part. With this technique, you don't. Whatever that response is, you flip it out of phase, and it totally flattens the mic out. And I'll show you some plots. For these microphones, it's like flat like a bench, man. It's from 0 to 60 or 50K, totally flat, awesome, very, very cool. And up to 60K, they're high res. So if you're recording at any kind of a high sampling rate in your computer system, these things kind of start to sparkle. You don't really hear up there, but it's all those harmonics that you kind of feel. It's like you just took a blanket off of a normal microphone and things just kind of pop out. So it's hard to describe, and just to give you an idea, this blue line, MKH. These red lines, whatever else. It could be Neumann's, it could be Schoeps, it could be Shure, it could be anything, any condenser mic. That's just, this is distortion measurements, non-existent, especially when you get up into the higher frequency stuff. So very, very cool stuff. So ribbon microphones, that material I passed around, it's aluminum, well usually aluminum, and a magnet. That's all that's in it. This is your whole thing. There's your magnet around the outside and this material in the middle, usually aluminum. Traditionally, you don't apply 48-volt phantom power to a ribbon microphone, traditionally. It's a bit of a myth, but you just be safe and don't apply phantom power to it. It's really not supposed to hurt it. It will only hurt it if things are kind of wired incorrectly, but don't do it. Unless you buy a new ribbon that actually tells you it's an active ribbon that needs phantom power, and then it has to have phantom. It just works like a condenser mic. It's got to have phantom power. So digital microphones. Again, I wanted to put this kind of as its own separate little category because they're becoming more popular now. You get the plethora of the inexpensive USB microphones that most people have seen or maybe used. Great for podcasting or plug it in your laptop for a quick tracking idea or something. There's lots of people besides Samson that makes them. There are also digital mic surface mount chips, like in my laptop. There's a little digital, I don't know, maybe Acoustica, some little digital surface mount chip in the laptop, so from a microphone. And then there are the AES-42 mics. AES-42 is a professional signal, and these are professional microphones. These are not USB microphones. They do not sound anything like a USB microphone. So Solution D is what the Neumann microphone is called, which is, sound hits the capsule, it immediately gets converted to digital. There's nothing else in between, which is the beauty of it. And the A to D, for us, the A to D is optimized for the particular capsule, whatever microphone it's in, which is why we don't make a generic A to D box like I wish we would. And it's a proprietary Neumann converter. What else would it be? It's Neumann, of course. They have to do everything themselves. But there's a reason for it, and it's because of this dynamic range thing. Most converters on the market, if not all, give you about 125 dB of dynamic range. That's kind of where they stop, and that's what most people want for the most part, or need. Neumann, of course, needed to do something a little bit different, so theirs gives you about 140 dB of dynamic range, which is why these mics sound the way they sound. And I'll talk a little bit about dynamic range a little further on. There are no bottlenecks for us. So you go, once it hits the A to D converter, it's digital from there on out. And it's digital down the cable, right into the back of your Pro Tools system or whatever computer recording system you're going into. There are no bottlenecks, what we call bottlenecking, which means the microphone has to hit the mic preamp, has to hit maybe a compressor, maybe an EQ, then an A to D converter, then into your computer. Once it does that, there's constant level mismatching and impedance mismatching, and you kind of squish, 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 squish until you get the end result. With digital mics, you don't get that sound. With digital mics, you get the mic, and from there on out, it's digital. There's no preamp, there's no compressor, there's no EQ to plug into unless you do it in the computer system. DSP is built into it. Compressor built in, phase reversal, mute, gain, polar pattern adjustment from your laptop or from your computer system. Pretty cool. And that's why we use AES-42. It allows this bidirectional control. AES EBU is the regular digital signal that most people use, and allows this bidirectional control data. So the microphone can send us data, basically what setting was stored in the microphone. It tells us what the microphone is. It tells us what polar pattern it was left at, if it was flipped out of phase or whatever. And then we can also send microphone data to it and tell it, all right, here, decrease your gain, or here, turn on your compressor, or whatever you got to do. So very cool feature. Again, no need for anything external, no compressors, no A to Ds, no nothing. You will save some money. It's a more expensive microphone, but you don't need the other stuff down the road. And this is kind of how the inside of it looks here, and it may be hard to read for you guys, but sound comes in, boom, converter, out digital. That's it. I mean, there's not much else in it besides, there's no tricks happening in this thing, let's put it that way. Polar patterns. Directivity is really the way, or the polar pattern is the way the microphone responds to sounds from around it, and we'll hear it a little bit. And there's a few major patterns: omni, figure 8, cardioid. These are the major ones that you're going to see. For the most part, there are some other in-betweens. So in a perfect world, omnidirectional mics look like this. Picks up all the way around the mic, totally 100% perfect, and that never, ever, 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 ever happens. This is the real world. They break this into the low frequency side of the microphone and the high frequency side, and here are the frequencies that it's measured at. These are pretty much the standard frequencies. And you'll see these bars here, these lines, and it corresponds to the frequencies that it's measured at. As you can tell, this dotted one right here is high frequency 16K. You know, it ceases becoming omni like this, and it starts becoming hypercardioid, supercardioid, a little directional. So at high frequencies, omni mics become directional. So figure 8 mics, again, you know, it shows you the degrees right here. You know, 0 degrees in phase, 180 degrees behind it, out of phase basically, and of course all the variations, high frequency side, low frequency side. Figure 8s pretty much respond the same at all frequencies for the most part. And a cardioid mic. Cardioid mic kind of does the opposite of an omni. At low frequencies, it becomes an omni. So combining omni and figure 8, the two main polar patterns, you get, again, I mentioned you get all these other ones. Omni adds some figure 8, creates cardioid, creates supercardioid, hypercardioid, shotgun, wide cardioid, different variations of all these. And again, it can be done either acoustically or electronically. Lies, lies, and specs. Specs, if you're trying to compare microphones and buying microphones, you're trying to sell microphones, and you have a customer looking at specs, they're not all BS. I was going to say the real word, but I'm on video. There's a lot of BS going on, let's put it that way. Frequency response, one of the basic mic specs that most people look at. The range of sound from lowest frequency to highest frequency that a mic can reproduce, basically. It gives me a quick snapshot of what this mic can probably do in a recording application. You don't know until you listen to it, but and there's a couple different ways they can do frequency response. A free field response is basically a measurement without reflections. It's in a perfect environment, which we never are ever in a perfect environment. Outdoor conditions could be close, like in a big field, or in, again, specific test conditions. So you can see right here, here's your free field microphone response. You know, a huge boost at 7K or something, that's crazy looking. That looks horrible. You probably never want to use that microphone until you see the diffuse sound field response, which is normal. And diffuse sound field is composed of your normal environment, reflections basically, any room that we're going to be in. So, you know, sometimes they show both of these. Most of the time people are just going to show diffuse sound field response. Sometimes people want to see free sound field response. And here you go, and here shows some different frequency response measurements. This shows that basically here's your normal response at 0 degrees on axis, and then it kind of gives you variations, 45, 90, whatever that says, 112, it's kind of a weird number, 135. If it's on axis or off axis, these all look the same. That's what most mic manufacturers want to strive towards. And you also have to look at the resolution or the scale. So scales, they can be totally changed to make their microphone look better, basically. It still gives you the same exact information, but if you're looking at things side by side, make sure you're looking at the right scales. That's all. And then sometimes, if you're lucky enough, you can get frequency responses like this. Again, I showed one on the other slide. 0 degrees on axis, 90 degrees off axis, 180 degrees totally basically behind the microphone. This is very cool, and I never used to pay attention to this. Now I do, because it shows you in this spot right here, this is the lowest level basically of this microphone, and this is, if you look at the frequencies, 300 hertz to 3K, this is exactly where your vocals sit. So behind this microphone is its lowest pickup pattern in that frequency range for vocals. So it would be perfect to use this mic with a floor wedge live on stage. Sensitivity, the electrical output of a microphone for a certain sound pressure. And the greater the sensitivity, the higher the output will be, basically. So if you're looking at sensitivities for microphones, higher sensitivity, less preamp needed. So if you're demoing two mics, the mic with a higher sensitivity will sound louder, and louder mics win. Doesn't matter what it sounds like. If you hear something louder in your head, you think it sounds better. That's just how we hear. Maximum SPL for THD, which is total harmonic distortion. This is basically how much SPL the mic is capable of handling at 0.5% of distortion, starting to give you some distortion, basically. And you know, if you use 1% distortion, and like we use 0.5%, if you use 1% distortion as a measurement, all of a sudden you get 6 dB better in your SPL handling. Doesn't mean the mic's any better. It just means it will give you more distortion at a higher SPL. So just make sure you're looking at the same measurements. Again, not everybody measures the same. Some people will use 5% THD, which is horrendous. Don't ever buy a mic that shows you 5% THD. You know, 10 dB better SPL. It looks a lot better. Not going to sound any better, but it looks a lot better. And microphone amplifier dynamic range. So this is the amplifier in the microphone. There's a little amp in the microphone. And I mentioned this because we were talking a little bit about the digital and the dynamic range of a digital microphone and the dynamic range of the A to D in the digital microphone. You know, it's measured in decibels. Bigger numbers, of course, are better because it handles a wider dynamic range. So can the dynamic range of the mic exceed the dynamic range of what we're recording to right now? That's the big question. So now we're at 24-bit DVDA, you know, 144 dB of dynamic range is kind of the widest, the biggest that we can get now. Microphones aren't there yet. Nobody's mic, I don't think, gets, as far as I know, gets up to that dynamic range. So he shows you dynamic range, analog tape, the old U47, old U67. Here's digital, TLM 170, TLM 102, which is a fairly new mic. Solution D, that's that digital I was just talking about, that D01. And then here is, you know, the pinnacle of digital audio right now. So in theory, you know, that Solution D microphone, it takes this much dynamic range. Well, the A to D converter is even wider, 140 dB of dynamic range, 140 plus dB of dynamic range. Again, still not as wide as what we're recording onto now, but this gets awfully close to filling the dynamic range of that capsule, of that converter in that capsule. So you start talking about digital stuff and converters and new microphones that can actually give you as much dynamic range as you need for this digital medium. It's just interesting to see the progression, and it's just going to go higher. I mean, this is definitely not the widest dynamic range for a microphone, but this is awfully damn close, and it's going to creep up, I'm sure, as people start making new microphones. Phantom power is, it's just, and I mentioned it a couple of times before, it's 48 volts applied to the microphone. These are both getting phantom power from my little Pro Tools M-Box thing back there. And it powers the microphone and it biases the capsule and it gets it to a level where we can use it. And just so you know, the spec for phantom power, it does vary. It goes up to 52 volts, down to 44 volts. This is one thing to check. Make sure whatever you're using, your mixer, your preamp, your whatever, actually gives you, well, 44 volts minimum. Not everything that says phantom power gives you this spec. It gives you 24 volts. It gives you 32.97518, whatever. It's whatever they feel like doing. And it's cheaper to not do a full phantom powered product. So if you plug a condenser mic in that really needs full 48 volts, and almost all of ours do, it's not going to sound good. It's going to sound something's off. You're going to check your cable. Man, it's not the cable works. It must be the board. Well, it's probably not, it is the board, but it's how much phantom it's putting out. And it's just going to sound thin and not quite there. You'll know right away. So we'll talk about some applications real quick, where to use Omni and cardioid and figure 8 and some other things. But first we have to talk about phase because it's so much fun. And the 3-to-1 rule. So phase it's really fairly easy. You got a sound source and you could have two microphones picking up the same sound source. In this case it's just a single sine wave, but picking up at different points in time. They're totally out of phase. One is all the way up, one's all the way down, vice versa. Totally out of phase, you get complete cancellation. So if this is a single frequency and these things are completely canceling each other, there goes your sound. It's totally gone. Most things aren't just single frequencies. Most music is, of course, multiple sine waves put together, which then we call comb filtering. It's phase cancellation at different frequencies. It just doesn't quite sound the way it should, almost like that phantom powering thing I was talking about. That's usually comb filtering, and comb filtering is probably usually not a good thing. Sometimes you might want to apply the effect for certain things. This is what comb filtering looks like. All these dips, that's all your canceled sound. So, and all you have to do is listen. You put the headphones on, you're out in the studio, and you move microphones until you hear it kind of become full, and then you're like, I'm in phase. So the 3-to-1 rule. This is a cool little rule of thumb to use. I keep referring to the studio, but could also be live stuff. 3-to-1 rule. 2 microphones must be placed at least 3 times the distance that either microphone is from its source. So, for instance, microphone 1 is a foot away from your big bald-headed singer here guy. Microphone 2 should be 3 feet away. Working distance. This is kind of, these are kind of arbitrary numbers, but I like to show it a little bit just to give a kind of a graphic representation of what mics will do at things at what distance. So, you know, you got your sound source here. An Omni mic, let's say you're micing it a foot away. To get that same kind of, or to, an equivalent, you can back a cardioid away a little bit further. You can back a super even further than that, a shotgun even further. A long shotgun even further, a parabolic mic even further away. It's just, again, these numbers, consider them in feet, for instance. They're pretty arbitrary, but at least it gives you an idea about what a mic will do for you depending upon the distance. And critical distance. This is important for a lot of classical orchestral type of recordings in halls, but the distance from the sound source at which the level of your direct sound has kind of fallen to the level of your reverberant sound or your room sound. I just wanted to bring it up. It's reverberation radius, you might hear that. If you record in a certain hall, they might have things marked off where the reverberation radius, critical distance kind of begins and ends to let you know where, oh, I got to put my, my binaural head or my Omni reverb mic, I got to get it, you know, if the critical distance is that second row of seats, I got to get it past the second row, for instance. That's all. Mic placement. This is the fun stuff. So the main thing, in my opinion, is really listening to what the thing sounds like in the room. A lot of times sometimes you don't have time to do that. The band comes in or in a live situation, but if you can hear what it sounds like in the room, get an idea, and then kind of reproduce that, hopefully with the correct microphone and the microphone placement. You know, that's what you're looking to do. If you can hear that guitar player playing, the acoustic guitar player in an ISO booth or something, and you know, walk around and listen to what it sounds like. If it sounds good in a certain spot, to your head, try to stick the mic there. See if it works. You know, it could, it may not. You know, we don't know. But at least you know what it sounded like good to you in that particular room, in that environment. Another thing to keep in mind: are there other things in the room that you need to keep out of what you're trying to record? And this would go back to the pickup pattern of the microphones. If you're doing a horn section and they're all live in one room together, instead of overdubbing each part individually, you want a mic that maybe will kind of pick up that one horn, that trumpet player, keep it out of the trombone player, and you know, and so on and so on. And what is the radiating characteristic of the instrument? How is that instrument, how is the sound coming off of that instrument? It's not what you might think sometimes. There's a lot of sound that goes all over an instrument, especially with piano and things like that. So classical music recording, a little bit different, but it's where you want to pick up the musicians and the room if you're probably going to be in a decent sounding orchestral room for the most part. Omnis for drum overheads, potentially, especially if you're in a good sounding room. Omnis for vocals. Omnis to me are the most natural sounding microphone. So, you know, doing it on a vocal in a decent sounding room sounds great. And it also has the flattest low frequency performance of any mic. So again, putting an Omni in front of a bass cabinet maybe. And situations where you don't want proximity effects. So cardioids and super cardioids like this, you know, the closer I brought it to my mouth, the more bass response I got, the more bass boost. And that's called proximity effect. And Omnis don't do that. And cardioids reduce the sound of the room, of course, because it's directional. Reduces the sound of the other musicians. Most stuff is recorded with cardioid microphones, for the most part. So figure 8's very cool. It's got that really, really sharp null on the sides. I love using them for horn sections because, again, you got the 3 guys sitting next to each other playing. You know, a figure 8 mic, a mic in figure 8 pattern on each horn player, sometimes that null point points directly to the guy next to him, and it's really, really, really cool for that. But use those nulls to your advantage, or use that, you know, it picks up in the front and also picks up in the back. Just the sides are dead. Maybe it's on a guitar cabinet in a little room like we got in here, and you want some of that room sound, some of the slap from the back wall. Well, figure 8 mic's going to pick up that slap from the back wall. So 3 different ways to record drums. Most of the time, a mic on every separate instrument or every separate drum or cymbal or whatever, and sometimes mic on the bottom drum heads. That's usually how most pop rock records are done for the most part. If you do have a mic on the bottom heads, make sure to flip that bottom mic out of phase, because they're both looking at the same sound source, and if you flip the bottom mic out of phase, they're not going to sound weird. And the more, like you were asking, the more mics you add, the more phase issues you're going to have, period. You know, this is the question you got to ask. What's the end result? What sound are you going for? Is it organic? Is it prog rock, very processed, individualized stuff? Are you going to be triggering samples? Are you going to have to gate? Or do you care about the drum sounds at all, because you're just going to be replacing everything with samples, period? So a couple of different things to do is, and we have it in here actually, multi-spaced room mics for different textures, which is kind of cool. See, but in this case, we had the stereo mic here. We had a mic, two U87s up here in the top. This is the stereo Neumann USM 69. And these overheads, which were considered our overheads, but because of the way these microphones are made, there's 2 capsules in the microphone, and we turned the back capsules on, which picked up all of this. The ceiling was really high, and it picked up all of this height up there. Maybe the far room mic is used during the choruses, and the close room mic is used during the verses, and then the bridge is something totally different. Whatever you want to do, blend them together, things like that. It just gives you options. Maybe use an effect mic to distort it and compress the hell out of it and EQ it and whack it out, or stick it in the bathroom. They have a bathroom area that I think Joey said when he does drums, he sticks a mic in there and just gets the reverberation of the bathroom. And it could be anywhere. It could be in the bathroom, it could be there, it could be put the mic in a bucket, I don't care, whatever. Jazz drums, which I mentioned a little bit about if you end up doing jazz stuff, or even if you just want to do a rock kit this way. Usually it's 2 overheads and a kick mic is kind of the jazz sound for the most part. The old sound, even old rock records and old jazz records, you know, they used 87s and M149s and old whatever condenser mics, because they wouldn't handle that much pressure, and you would get that distortion, that good sounding distortion, and that compression, and the mics kind of squash, they self-compress, they kind of hold themselves in, and you start hearing some of that distortion, which gives you that kind of that warm overhead sound. A lot of times now, especially for jazz stuff, you know, using these small diaphragm DPAs or the Sennheiser MKHs or whatever, or the Neumann KM184s, and it's definitely a more modern, brighter, crispier sound. And if you need more snare, move the overheads directly over the snare. It's funny how little you can move a pair of overheads, how drastically the sound changes. I mean, I'm talking an inch. You move the overheads over an inch, your whole image shifts, your whole stereo image shifts, snare pops out, that floor tom that was killing you goes away sometimes, or maybe you move it an inch and you pick up too much hi-hat. It's amazing how things change with an inch. Moving them closer brings out the details, gives you more rack toms. Maybe that's not what you want though. Maybe you want more of a roomy overhead sound. And closed jazz kits, this can be a pain to record sometimes. So you can put an Omni on the actual beater side, the pedal side of the kick drum. But you think an Omni, it's going to pick up everything all around it. Exactly. It will give you the kick drum, the floor tom, and the snare, and depending on how you move it, that's going to be your snare mic potentially. So it's a cool, I'll show you a picture about it. But this one thing, if you put an Omni on the actual kick drum side, the kick side, the drummer side, you're going to have to flip the polarity, because you're hitting the drum this way, drum's moving air that way, but your mic is here expecting to see sound this way. So you got to flip the polarity of that mic so it sees the sound coming the right way, basically. Not turn the mic around, but flip the polarity of the capsule. There's an Omni mic, there's your floor, here's your snare, there's your kick, and this kind of gets all of that, basically. If you don't have a kick drum with a hole in it, which most jazz guys have closed head kick drums. So. Retro drums, yay! I'm old, so I like retro drums. The Bonham sound. If you guys know who Glyn Johns is, or John Bonham, the Led Zeppelin drummer, and you've heard the old Led Zeppelin records and that big thunderous sound, well, part of it is John Bonham being a monster and how he plays. The other part of it is Glyn Johns and how it was recorded years ago with not the current technology. He did 3 microphones, and this is the coolest thing to try if you have time in a session. You set up all the mics the way you want it to, and if you can find 3 of the same microphones and set them up and try to do this John Bonham sound, it's really, really cool, and you'll be amazed at what it sounds like. And basically, all these 3 mics, and these look like sure SM57s, but I wouldn't use an SM57. I probably would use like a large diaphragm condenser of some sort. All 3 mics are kind of equidistant from the snare, pointing directly at the snare. So this is your overhead mic. And what I used to do is the 3 drumstick thing. So I grabbed 3 drumsticks kind of in a row, and that was my measuring thing. So I'd put it on the snare, and at the top of the 3 drumsticks, I'd plop the 1 mic. And then I'd point it over towards the floor tom. And at the top of it, I'd put another mic right here, basically covering kind of, it acts as your overhead actually, which is kind of weird because it's below the cymbals and it points right at your floor mic, but it picks up a lot of overheads. And then you kind of do the same thing with your kick drum, and that's hard to get your mic sticks through here, of course, but you can eyeball it and try to put a microphone out pointing directly at your kick drum at kind of that same difference, pointing at your kick drum or pointing close to your snare. And you bring the 3 faders up, and it sounds like, if it's in a good room, it sounds like John Bonham. It's awesome. It's very, very, very cool to do. It's super easy to do, and you don't need a lot of tricks, just the 3 drumsticks and measure it and place it. It's really cool if you can try it. And a vocalist. If you can listen to the vocalist before you select the mic, great. Sometimes you can't. Guest vocalist comes in. You got to have them cutting vocals in 5 minutes. Pick the mic that you like to use. I used to always go with an 87 because it's what I knew sound-wise. The U87 was what I grew up listening to, and that was my first mic. And if I couldn't go to any other mic, I would stick with it. But it would give me a reference that yes, it worked, or no, it didn't, and I would know why because I knew what it sounded like. So, with a vocalist, factor in what they're going to be singing. Is it jazz? Is it rock? If it's rock stuff, it's going to have to cut through these barrage of guitars. You're probably going to need a mic with a little bit of high frequency lift to get it to cut through. Like the TLM 103, which we have in there, is a mic with a really pronounced lift on purpose. And EQ, again, you're adding noise, you're adding distortion, you're adding something else in the signal path, even if it's digital. So if you can not EQ something, whether either moving the mic or choosing the right mic with the built-in EQ curve, basically, it's much better than adding EQ after the fact. It's kind of the pristine way of doing it. And we mentioned this earlier, once you compress vocals and record them, and this is anything, once you compress them and record them that way, they're always going to be compressed. So if you squash the crap out of it and it doesn't sound good, you either get them back in to re-record or you're stuck with a squashed vocal, and you got to make it work. And a good way to shoot out mics are having one on top of each other. Nice, convenient way to do it. So get the mic about 8 inches away if you can, ideally. Closer, again, is going to give you more of that proximity, more of the bass boost if you want it. And if you don't want it, you don't want it close. So, and you're going to get popping. You're going to get the in the microphone all the time. So a couple of ways you can do it. Use a popper stopper, a little filter type of device. This is huge. Not all these are created equal. We have some in the other room. Hold one up and talk through it or blow through it and see how much air you feel in your hand, or hold a lighter up and blow through it and see if you can blow your lighter out. Because some of them, even though you think they're very good and they cost a lot of money, let an insane amount of air through. And other ones that could be very inexpensive might work great. All of these things put in front of the microphone will alter your frequency response. And it's at about 15K you start to see it brings your high frequencies down a little bit. And one way to do it is without. If you don't want to use a popper stopper, and if you have a good vocalist, angle the mic. A little 15-degree tilt will take that air from hitting directly to the capsule, and all of a sudden that capsule's tilted and the air doesn't hit directly into it. And if you hear the popping and you move the mic further away, it only gets worse because it has more room for that pressure out of your mouth to travel. But if you put a pencil, tape it to the mic stand, or tape it to like right in front of the microphone, without a popper stopper, that little piece of wood or a pen or whatever will disperse the sound enough to keep it from hitting the diaphragm directly. It's kind of cool. And it won't really alter the sound of anything. So it's a cool way to put a little pencil up there. Stereo miking, this is the end of it here really quick, but normally used in classical music applications where you had to get the hall and you wanted a stereo image of the entire orchestra, basically. Compatibility with mono, if that's an issue for you, like for TV or radio, make sure you pay attention to that. If the stereo miking will compress or collapse down to mono right. And if it doesn't, then you may not want to use it. So AB, stereo miking, Decatree is a version of it. Mid-side, which you may have heard. XY and Bloomline is a version of that. ORTF, which this is that chart that I had that I like to use. Again, all just different variations of, can get you a very similar sound. And binaural. AB is just a pair of spaced Omni microphones. Creates a very wide stereo image. Doesn't collapse down to mono very well, and there is this cancellation frequency. You know, basically you take the speed of sound and divide it by the distance in feet between the two microphones, and that frequency cancels. It goes away. And then Decatree, which is really cool for orchestras if you can do one inside of a studio. Here's your AB, here's your wide pair, and they basically add a center fill mic to it. That's all. Upside down, it's usually hung from the ceiling, and they point down. They're Omni mics. If you ever see pictures or video of a big orchestral recording session, they probably have a Decatree above the conductor, which is awesome. So, mid-side, which is kind of a cool thing to do now. For a lot of people use this. You can either do this in the computer with some kind of a plug-in that will allow you to do mid-side, or we have some preamps in there that actually have mid-side built into it, that you hit a button and then you can do the controls to change the stereo width and everything. Or you can do it the old-fashioned way on a mixer, 3 inputs on a mixer, and I'll show you that. Great for mono if it collapses well to mono. But using 2 microphones, this one's in figure 8, shooting to the sides. Here's a cardioid mic shooting directly ahead of you, basically. Here's how all the polar patterns kind of look together. And this is the way to do it the old school way. And again, I'm old, so I do it this way. The mid or the cardioid mic pointing directly at you goes to 1 fader. The figure 8 mic goes to 1 fader and then is also malted to another fader, and that second channel is then flipped out of phase. And then this is your stereo width, so then you use the pans to change your stereo imaging. So XY, probably the most basic one that most people use, 2 mics at 90 degrees to each other. It does have this sound buildup. Sound builds up right there, so if you have a stereo XY thing over a drum kit and it's right over one of your cymbals, you're going to hear a whole lot of cymbal. And it's generally less space and depth than a wide AB. Bloomline, it's basically an XY but with 2 figure 8 microphones. Sounds very, very, very cool if you can get 2 figure 8 microphones, which are not that popular or normal for the most part. So ORTF, which is another one I like. This to me sounds really, really natural, so I like it. It's very specific. Capsules have to be 17 centimeters apart, and they have to be spaced on 110 degrees. If not, you get some weird phasing going on. NOS, which is a version of ORTF, that's all. Just a different distance and a different angle. You guys ever heard of binaural recording? Like the heads, it's basically a head with 2 microphones in it, like where your ears are. It's awesome. The dummy head, although don't tell it that it's a dummy head, it basically sounds like you're in the room with whatever you're recording. It's really, really cool. People do it to record car cabinet noise inside of a car. You see all the testing and stuff. The dummies, sometimes those dummies have microphones in their ears and they record what the noise is in the cabinet. A lot of orchestral stuff done with binaural heads, a lot of outdoor stuff. And it uses, it works how your ears work, left and right info and frequency dependent stuff. So it works on how sound can get to one ear and then has to travel around your head to get to the other ear. And a good binaural head usually has the same structure of your ear built into it and the same type of material that your ear feels like and the whole deal. So it acts as skin and bone and everything else, which is really cool. That's Fritz. That's the Neumann one. You get the ears. He's so handsome. And real quick, just so you guys know, these things are extremely, extremely sensitive pieces of equipment, not just ours, but anybody's microphone. Like, you know, the distance between the diaphragm and the back plate, the ones I passed around, it's like 3 or 6 microns. You know, hair, the thinnest hair is like 17 microns. So these are a lot, the space between these things is that tolerance level. If that mic gets dropped and that diaphragm starts touching the back plate, you know, you're only dealing with a few microns. So it's be very careful with them and don't throw them around. And yes, they can take a beating, and yes, they can be dropped. I wouldn't recommend dropping any of them, but and dust and moisture and everything else and smoke and all that kind of stuff is not good for microphones. And condenser mics especially are very susceptible to a lot of stuff, really smoke. And if you have good, expensive microphones and you use them fairly often, have them cleaned every 3 to 5 years. It will, paying for the cleaning, which could be $300, $400, $500, probably about $300, is a lot cheaper than having a capsule replaced. Because after 5 years, if you haven't cleaned that capsule and it's been used in a studio with a lot of smoke or whatever, all of a sudden it can't be cleaned. You got to replace it. Next thing you know, the $300 repair goes to a $2,000 capsule. So today, very cool local band called Digital Antique. If you guys have heard of them or not, I don't know. I'm not from the area, but instrumental band, but they have a guest vocalist with them, this guy from Obsolete Machines. I think you guys are going to like these. It's very, I've heard them on MySpace, on their websites and stuff. Very, very cool stuff.
Feels much better when you're running now.